Okay, now for the calculator paper. So, following diagram is a circle. We need to find the arc ABC. So we're trying to find this arc here. Here we go, length of an arc. Let me just do both of these because I think we need both. So, this is where you need to remember that despite the fact that they've given us these two formulae, the theta, the angle theta has to be in radians. Now, luckily for us, it is in radians already, so we don't have to do anything with it. So, length of the arc is just 1.3 multiplied by the radius, which is 3. We don't even need a calculator for that, 3.9. So find the area of the shaded region. Now note, if this angle here is 1.3 radians, this is the angle we want for the shaded area. That angle there would be 2 pi subtract 1.3. So 2 pi subtract 1.3 gives us 4.98318. Actually, we'll just leave that in the calculator. So we're going to use this formula here now, a half theta r squared. So area is 1/2 times 2 pi minus 3.9 times 3 squared. Let's take that one later. So the answer multiplied by 0.5 multiplied by 9, 22.42. That's right. And that rounds to 22.4. What units are we on? Centimeters squared. Remember rounding to 3 sig fig. Next one. Okay, so this is where you were given the help for part B. You shouldn't have needed any help for part A. We're talking about probabilities. We know that probabilities have to add to 1. Therefore, for part A, 0.2 plus 10k squared plus 0.4 plus 3k has to equal 1. We know that probability equals 1. So 10k squared plus 3k, we've got plus 0.2 plus 0.4 is 0.6, and then we have to equate it to 0. So that's minus 0.4 equals 0. It's a calculator paper, so we don't need to stress. We just use Polysmalt. And I just can't see, so A is 10, B is 3, and C is negative 0.4. Oops. So we've got, X is, well, in this case, K. K is negative 2/5, or K is 1/10. Well, we can't have a negative value of K, so in this case, K has to be 1/10 or 0.1. Find the expected value of X. The example that was given to you in the exam was supposed to help you. Once we've established that K is 0.1, we then multiply these values here and add them together. So negative 1 multiplied by 0.2 plus 0 multiplied by 10 times 0.1 squared plus 2 times 0.4 plus 3 times 3 times 0.1. Obviously that's going to be 0, so we've got negative 0.2 plus 0.8. 3 times 0.1 is 0.3 times 3 is 0.9. But obviously you've got your calculator, so you don't need to do this in your head. So negative 0.2 plus 0.8 is 0.6 plus 0.9 is 1.5. So the answer is 1.5. Fx and gx, we have to solve fx equals gx. It's in the calculator paper, so we just substitute them into our graphing calculator and equate them. We'll find where they meet, sorry. So, this. So we go into y equals. So our first one is x squared. Our second one is 3 ln x plus 1. And they want for x greater than negative 1. So let's just check our window. Okay, maybe we'll go to negative 2. Let's go actually, just go to standard to see what it looks like. Okay, so we need to solve those 2 points. So we go to second, calculate where they intersect. First curve, second curve, guess. So they intersect at 0, 0. And second, calc. Scoot it over to near the other point. Oh, that's not what I wanted to do. Second, calc, intersect. First curve, second curve, guess. So the other point is 1.74. Okay, remember round into 3 sig. Right, so there are 2 values that we've solved. We need to find the area of the region enclosed by that. So that means that we know that we are doing definite integrals between these 2 values. So remember, our calculator does that for us. So we quit this. Oh, actually, we can do it in there. Number 7. So our lower limit is 0, and our upper limit is 1.74. Oh no, I know we have to input it. Okay, so let's not do that. Apologies. So we go to math 9, as I recall. Yep. So our lower limit is 0. Our upper limit is 1.74. We put this in here, so we need to find x squared minus ln x Oh, 3 in an x plus 1. Oh. Oh my gosh. Yeah. Oh. So it's negative 1.31. But remember, we ignore the sign when we talk about the area.